Hello grade 11s, we're going to start having a look at each homologous series. If you remember in the last videos, I explained what a homologous series and a functional group is. The homologous series is the class of organic compounds, and it's a bunch of similar compounds. So for example, alkanes, they are all hydrocarbons, and what makes them alkanes, what identifies them as an alkane, is the functional group, which is there are only single bonds between the carbon atoms. So if we look at the information from our notes, alkanes, that is what the homologous series, the class of organic compounds, is called. As mentioned, they have only single bonds between the carbon atoms, and that is the functional group. That's how we identify that we have this homologous series. Now, for alkanes, they are only hydrocarbons, so their molecules only made out of hydrogens and carbons. We say that these compounds are saturated hydrocarbons, and saturated means they have single carbon-to-carbon bonds, and they cannot undergo addition reactions, and we'll cover that later on when we do organic chemical reactions. They have relatively weak intermolecular forces. Now, if you remember from the videos on intermolecular forces, I always told you that hydrocarbons are non-polar molecules, and we know that the intermolecular force between non-polar molecule is the weak London dispersion forces, or weak London forces. Now, the first four alkanes, which are methane, ethane, propane, and butane, and I'm going to explain about the naming later on in this slideshow, they are gases at room temperature. The next five are liquids at room temperature, and then only molecules with 12 or more carbons in their parent chain are solids at room temperature. Now, if we have a look at this molecule over here, the gray circles are obviously, or we call them the gray balls. This is a ball and stick model. So the balls, which are gray, are carbons, and the white ones are the hydrogens. And if we are to count them, we get 5 carbons. Now the general formula, each homologous series has a general formula that applies to that homologous series. So here it is CnH2n plus 2. Now the N represents how many carbons there are, and I counted, there are 5. So we replace the N with 5. So then 2, and the N is 5, so 2 times 5 is 10, plus 2 is 12, and that represents our 12 hydrogens. We need to remember that every carbon bonds 4 times. So all alkanes will fall into this general formula, CnH2n plus 2. In physics, when we say SI unit, it's the unit that we use when calculating certain physical quantities. And if we say the SI unit, the standard international unit of mass, say, is the kilogram, that is what around the world people will use as the unit for mass. Now, there's also a standard way of naming organic compounds. So for example, you don't get away in South Africa, and then in Britain it's a different way, and in America it's a different way. There's a standardized way of naming it, and we call it the Aiyoo system. Now, Aiyoo stands for International Union of Pure and Applied Chemistry, and this is the method that we are going to use to name organic compounds. So now the prefix of 1 to 10 over here, in the SAGS documents say we only have to go up to 8 carbons. So if I say meth, now we've done methane before. Now meth actually represents 1 carbon. And so as we go 2, it's eth, 3 prop, 4 but, 5 pent, 6 hex, 7 hept, 8 oct, like octopus, 8 legs, 9 non, and 10 dec, like a decade is 10 years. So that prefix tells us how many carbons are in that particular molecule, in the parent chain of the molecule. And I'll explain what that means a little bit later. And for the homologous series alkanes, to represent that they're only carbon-to-carbon single bonds, we end it in ane. So the simplest alkane is methane. The meth is saying one carbon, and the ane is it belongs to the alkane homologous series that only has carbon-to-carbon single bonds. Remember, the CH4 here is the molecular formula. If we show all the bonds, that is the structural formula. Here we can see a three-dimensional shape for methane, and we'll recognize it as being a tetrahedral. Now, ethane, the eth means two carbons. So you can see here we've got two carbons in the carbon chain, and the ane means it is an alkane that only has carbon-to-carbon single bonds. Now, this also falls into the same general formula. If we've got C2, the 2 would be the N, and then 2N would be 2 times 2 plus 2 is 6, and that's where we get the 6 hydrogens from. So ethane would be our second one. Prop would mean 3 carbons. The ane, carbon-to-carbon single bonds, it belongs in the homologous series alkanes. Butane, the but represents 4 carbons. The ane represents carbon-to-carbon single bonds. And all of these will fall into the same general formula, CnH2n plus 2. If we look at the definition for a homologous series from the SAGS document, it says an homologous series as a series of similar compounds. So the similar compounds, they are all hydrocarbons, which have the same functional group. Now remember, for alkanes, the functional group is the carbon-to-carbon single bond. That's what identifies it as an alkane. They have the same general formula. Now remember, the general formula we've discussed for alkanes is CnH2n plus 2, in which each member differs from the previous one by a single CH2 unit. So if I go to the previous slide, if we go from CH4 to C2H6, the one differs from the next one by a CH2. If we add a CH2 to C3H6, we add a CH2, we get C3H8. And so that's how it forms a series. There's an addition of a CH2 every time, and that is covered in the definition of the homologous series. Now, if we look at this alkane that we discussed just now, it was 1, 2, 3, 4, 5. So 5 carbons is pent, and they're only carbon-to-carbon single bonds, so it's ane, so it's pentane. Now over here, you can see that there's a main chain over here. That would be called the parent chain. Now this over here would be called an alkyl substituent. Basically, it's a branch. Now, when we are naming the alkane, if it has a branch, you can't just count all the carbons together and all the hydrogens together. There's a definite way you have to name it according to the Aiyoo naming system, and I'll discuss that in the next slide. So if we look at this pentane, so this is the ball and stick model. It's a more three-dimensional version. If we were to draw it out in the structural formula, remember that shows all the bonds. This is the main continuous chain. There isn't any hydrogen that's been replaced with anything else. So there are 5 carbons, that's represented by the pent, and the ane represents that it's an alkane and it has carbon-to-carbon single bonds. Now, if we have a look at this example, we have a continuous chain, which is 1, 2, 3, 4, 5, but we have this branch over here, and that branch is also called an alkyl substituent. So if it's made of carbon and hydrogens, we call it an alkyl substituent. Now, over here, this branch over here has a carbon and it's got 3 hydrogens on it. Now, if it's an alkyl substituent, it ends in YL. So what we have to do is we have to identify the longest continuous chain. And so I've put it in a blue block over there. So we've got the longest continuous chain, and that is called the parent chain. And that would be pentane, because we've got 1, 2, 3, 4, 5 carbons pent, and it's all got single bonds, so it's an ane. So now what I have to do, I have to number my carbons, and on the next slide I'll explain in more detail how to number the carbons. But we can see on the 3rd carbon is where we have that alkyl substituent, and we have to give the address of where it is on the parent chain. So we say it's on number 3. That's the address of this alkyl substituent. Now, we name the alkyl substituent by how many carbons it has. So here it has 1 carbon, so it's a meth. And because it's a branch, it ends in YL. So over here, the address is on the 3rd carbon. There must be a dash over there. This is part of the Aiyoo naming. The meth says that it's 1 carbon, and the YL tells me it's an alkyl substituent. It's a branch. So it's saying on the 3rd carbon, there's a branch, because of the YL there, there's a branch that has 1 carbon and 3 hydrogens, and the parent chain is pent 5 carbons, and it has single bonds, and there's no space between the methyl and the pentane. So 3-methyl pentane would be the name of this molecule, which is a branched alkane. So if I had to put it into steps to help you, so here I've got an alkane. There's only carbon to carbon single bonds. I must identify the longest continuous chain. So here it's 1, 2, 3, 4, 5, 6. This could be a continuous chain, but 1, 2, 3. But then it's not the longest one. So I've identified the longest continuous chain. Then step 2 is number the chain so the substituents, the alkyl substituents, are on the lowest address. So over here, this would be considered a branch. And so now, if I number this carbon 1, 2, 3, 4, 5, 6, this substituent will be on the lowest address, number 2, because if I numbered it the other way around, so it isn't a case of you have to number from left to right or right to left. So in this case, if I'd numbered from right to left and I made that carbon 1, then my branch would be on 1, 2, 3, 4, 5. And so I want to have my branch on the lowest address. And then if you have more, so you identify the substituent. So our branch has 1 carbon, so it's a methyl. And if we have more than 1, we put it in alphabetical order. So we know the parent chain over here has 6 carbons. So 6 is represented by hex. The ane it's representing the single carbon to carbon bonds. The correct way of numbering would be from left to right because it puts the branch on the 2nd carbon. So then we would put our address, which is number 2, dash, meth, because our branch has 1 carbon. The aisle is telling us it's a branch, and then there's no space between the methyl and the hexane, and that's our parent chain. So this would be called 2-methyl hexane. If you named it 5-methyl hexane, it would be incorrect because it would be incorrect according to the Aiyoo naming system. And then here are a few uses of alkanes. So methane is a natural gas. It is produced naturally in the ground. It's also produced by cows. It's in there's butane. Methane obviously can be lit and it can be used as a fuel. butane in lighters, fuels, Vaseline, commercial gasoline, and petrol. So alkanes have many uses, and I'll